Greetings and welcome to another ReMBlock screencast. In this screencast, I will show you how you can send value from a smart contract to a wallet using Yul. We'll first of all take a look at a contract which uses Solidity, which is this one here, transfer value 1, and then we'll look at the Yul version, which is in transfer value 2, which is in this function here. So in Solidity, which you're probably familiar with, is you will wrap the address that you want to send the value to as a payable address, like so, and then you call the call function, passing in any value that you want and any ABI encoded data, like so. So this is the syntax that you're probably most familiar with. Essentially what you're doing is you're sending a transaction to this address that is payable, so you're able to send value, and the value that you're sending is the balance of this address, i.e. the balance of this contract. Now this contract will have a balance because I've made the constructor payable, so when I deploy this contract in a minute, I will send in a few ETH to make sure that we have some value to test. Now notice I've got the owner set to a constant address, which is one of the addresses here that we're given. In fact, it's the second one here. And we can see that we have a Boolean that is returned here, which is basically to check the state of the transaction. So if this returns false, then the require statement will fail and the transaction will revert. So we are looking for a true value, meaning that the transaction went through successfully, and then we are good to go. Now let me just compare that with the version in Yul, which is functionally the same, functionally equivalent. Now, first of all, the interesting thing to note is that this Yul version is actually more gas efficient. Now, the way that we do this in Yul is we use the call opcode and we pass in the gas. So we're forwarding all the gas to the next wallet address, which is the owner. And so that's the address we want to make the call to. And the value that we're passing through to this is the result of self-balance. Now self-balance is the equivalent of this, and actually if we look at the Yul docs you can see here that self-balance, which should be here, is the equivalent of balance address but cheaper. So this is one of the reasons that makes this Yul version cheaper to execute. Now these zeros here, if you remember, the call statement has a area of memory that is used to forward some call data to the destination. So it's the equivalent of this ABI encoded data that we send here, which is empty. So that's why we make this 00, because we're not going to send any data to this transaction. We're just sending some value to this transaction, or to this address. In this transaction. And then the 2 zeros at the end here represent the area of memory that we want to write the result to, the result of the call. And again, we're not interested in that, so we leave this as 0. And it's the same, this part here is the same as basically the call data returned in this slot. So we might normally write something like bytes memory result or something like that, right? And that's where we would take the result of this call, and as you can see here we're getting an error saying, or I think a warning just saying that it's unused, and it's true, we don't actually need to use it, so we'll just remove it. So that's why we leave this blank and we leave this 0, because we're not interested in the result. Now this part here of course is the same as this statement here, where we're checking that the return value is false or true, and in this case we're checking if it's 0. So if it's 0 it means it's false, which means the transaction reverted, and we want to revert our transaction here as well. Now what I'm going to do is I'm going to deploy both of these contracts and test this out. So we'll start off with the version 1, the Solidity version, so transfer value 1, and I'm going to deploy it with 2 Ether. So let's see here, let's get some Ether. Let's see, yeah, let's deploy with 2 ETH and expand this out. Now I've got a couple of helper functions just to check. We got the owner, which is this AB address, which is the second address in this list. And the balance, we got the 2 ether there. Now if I click withdraw Solidity version like this, we can see this transaction executed, and we can see that the execution cost was this 9,780 gas. So let's make a note of that here. We can see this, and let's just make sure that our second wallet here received some ether. Yes, it's received extra ether here. At the beginning the balance was 1 ether less. I think it's 108 and now it's 109. In fact, we can check the value or balance of this contract is now 0. So that's good, that's worked. Now let's take a look at the second version and deploy that. Actually, I should have deployed it with some ETH. So let's deploy it with 2 ETH. We deploy, we come down here, we check the owner, we check the balance, it's 2 ETH. We call the withdraw Yul version, and we expand. The execution cost of this was, as you can see, much less. In fact, we can just subtract the 2, but it's about 300 different. So we take the value of the Solidity version, and we'll subtract the value of the Yul version. You can see the difference is 273. So it says 273 gas with the assembly version. And we can check as well that the increased balance of the owner wallet there. So that's a quick demonstration, an example of how we can write a withdraw function in Solidity and in Yul, and how when using Yul we get a cheaper execution cost. So I hope you enjoyed this, and I'll see you in the next video.